Hi everybody. Okay, in this video, we're going to continue working with chain rule. So I'm just calling this chain rule part 2. And we're going to start by looking at nested product quotient and chain rule problems. So with some of these functions, you're going to have to use chain rule in conjunction with product and quotient rules. It can take a little bit more planning and organization, okay, but it's not really too bad if you take it step by step. And that would be my best advice, just take it step by step. But then I do also want to show you maybe a different take on simplifying. So let's look at this first example. H of x equals 2x squared times 4x minus 3 cubed. I do want to say you could use power rule with this, but remember 4x minus 3 cubed means you'd have to multiply 4x minus 3 times itself 3 times. So, I don't know, that could be kind of tedious, but if you wanted to do that, you could. Or another take on it would be use the product rule, okay, but within product rule, we're going to use chain rule. So, we're using product rule because we have f of x times g of x. We're multiplying two functions. So let's just break it down into our two functions. F of x would be 2x squared. So then f prime would equal 4x. Okay, g of x would equal 4x minus 3 cubed. So this is going to require chain rule because we have the outside function, which is like your candy coating on an M&M. And we have our inside function. Okay, so remember, chain rule essentially works like this. You start with the derivative of the candy coating, okay? So your candy coating would be this. So that's going to be bring the 3 down, subtract 1 from your exponent. But then remember, you plug in g of x, but then you multiply it by g prime. Okay, and then we can just simplify, multiply the 3 times the 4, and get 12 times 4x minus 3 squared. Okay, so now we're going to set up our product rule. So at this point, it's like cross multiplying. Okay, so h prime is going to equal 2x squared times 12 times 4x minus 3 squared plus 4x times 4x minus 3 squared. Cubed, excuse me, 4x minus 3 cubed. Okay, so that's our product rule. Remember, you could also remember it as, first times derivative of the second plus second times derivative of the first, okay? Okay, now, as far as simplifying goes, we can do a little simplifying in the beginning by multiplying the 2x squared times the 12 and make that 24x squared times 4x minus 3 squared, okay? Plus 4x times 4x minus 3 cubed. Okay, so here's our little simplifying trick or technique. Remember, simplified form is factored form. So we actually want to factor this, okay? I don't want to FOIL out 4x minus 3 squared, and I certainly don't want to have to multiply 4x minus 3 times itself 3 times. So we're not going to do that, okay? We are going to factor. Okay. Now remember, the terms are what's being added, okay? So this is a term, and this is a term. So I want you to think, what is common to both terms? Because we're just going to factor out the greatest common factor. Okay, so what is common to both terms? Well, if you look at the 24x squared and the 4x, we can factor out a 4x. Okay, then we have 4x minus 3 squared, and we have 4x minus 3 cubed. So we could factor out the 4x minus 3 squared from each term. Okay, so what is that going to leave? Well, if we take 4x out of the 24x squared, That'll leave 6x. And then remember, we've already factored this out, okay? All right, plus, we factored out 4x, but if we factor out 4x minus 3 squared from the cube, that's going to leave a 4x minus 3 to the first power, which I'm just going to write as 4x minus 3. Okay, then all we have to do is just simplify what's in the brackets. And so 6x plus 4x is 10x minus 3. And now we are done. This is simplified because it is factored. Okay, so it's just a little bit different take on factoring. But essentially we just factored out the greatest common factor. Okay. All right, let's look at another example. Okay, so again, here we're also going to use product rule and chain rule because h of x is equal to 5x times the square root of x squared plus 1. But I would probably rewrite it first as 5x times x squared plus 1 to the 1/2 power. Okay, so now we've got 5x is f of x, and x squared plus 1 to the 1/2 is g of x. Okay? All right, so let's break this down. Find each derivative. Okay, now, the derivative of g of x is going to require chain rule. Okay, so here's your candy coating, like your M&M. So we're just going to use power rule with that. So it's going to be 1/2 brought down times the chocolate, but then to the negative 1/2 power, because we're going to subtract 1 from our exponent. Okay, and we're going to put the chocolate back in, which is g of x. And then we're going to multiply by the derivative of x squared plus 1, which is 2x. Okay, so now we're going to do product rule. And so h prime of x is going to equal f of x times g prime. I'm going to use brackets here because that's a little lengthy. Okay, plus g of x times f prime. So that'll end up being 5 times x squared plus 1 to the 1/2 power. All right, so that's our derivative, but let's try to simplify a little bit. So I'm kind of noticing that I can multiply the 1/2 times 2, which would equal 1, and then I can multiply the 5x times x, which is 5x squared, okay? Now, because I have x squared plus 1 to the negative 1/2, that's going to move to the denominator, and I'm just going to take it back to a square root. Okay, then I'm going to have plus 5 times the square root of x squared plus 1. Okay, now, how do we simplify from there? Well, we are essentially adding fractions, so we need to find a common denominator, okay? Right now, this would be a fraction over 1. So we would end up multiplying top and bottom by the square root of x squared plus 1. Okay, now, in our numerator, well, let me just bring down the first fraction. Okay, in our second fraction, if we multiply straight across, we're going to end up with 5 times, well remember, square root of x squared plus 1 times itself is going to get rid of the radical. So that'll become just x squared plus 1. Okay, over the square root of x squared plus 1. All right, but now we have a common denominator, so we can just add our numerator. So this will end up being 5x squared, and I'm going to go ahead and distribute this 5 plus 5x squared plus 5 all over the square root of x squared plus 1. And then we're almost finished. You can combine like terms. And voila, we're finished. So there, this Okay, the simplifying got a little tricky. I think finding the derivative was easier than simplifying. But we essentially were just finding a common denominator and then adding the fractions. Okay, here's another example. So here I wanted to show you an example where we're going to use chain rule and quotient rule, okay? But we're really going to start with chain rule in this case. So we're going to go ahead and kind of break this down like we did today. F of x, or the candy coating, is this, okay? And then g of x is the quotient, okay? So if I find f prime, that one's easy because that's just going to be 2 times whatever's in parentheses to the first power, okay? Now what's going to take a little bit more work is g prime, because that's where I have to use quotient rule. Okay, so I'm just going to work that off to the side a little bit. So we're going to go low d high minus high d low all over low squared. All right, and then simplify my numerator. I'm just going to distribute, and also distribute that negative. So I'll get 3x squared plus 9 minus 6x squared minus 2x. Okay, combine my like terms, negative 3x squared minus 2x plus 9, and then put that over the denominator. Okay, so you guys, this is g prime using quotient rule. Okay, so now we're going to find essentially quotient rule, so f prime of g times g prime. Okay, so we would end up with 2, remember I'm going to plug that in there, times 3x plus 1 over x squared plus 3 times g prime of x. Okay, woo-wee. So that is the derivative. This would be h prime. Hope you're following all my work here. So, as far as simplifying that goes, we could multiply straight across. So in that case, this would be like 2 over 1. Multiplying the denominator is easy because this is x squared plus 3 to the first power. So in that case, you're just adding your exponents. You get x squared plus 3 cubed. Now the numerator would take more work. You could distribute the 2, and then that would become, again, I'm going to work it off to the side, 6x plus 2, but then we'd have to multiply that by the negative 3x squared minus 2x plus 9. And so then in that case, we're just going to have to multiply everything out. So 6x times negative 3x squared is negative 18x cubed. 6x times negative 2x is negative 12x squared. 6x times 9 is 54x. And then distribute the 2, so we get negative 6x squared minus 4x plus 18. Okay, combine like terms. Okay, I'm seeing negative 12x squared and negative 6x squared, so negative 18x squared. 54x minus 4x is 50x plus 18, and so that is essentially our numerator. So as you can see, it's the algebra that gets a little tricky here, and that's why I always say take it step by step. All right, that is h prime. Okay, next I want to show you a little bit more chain rule with trig functions, because sometimes your trig functions can be in the form of f of g of h of x, where you're actually dealing with 3 different functions. Here's an example. We have cosine cubed of 4x. which remember means the same thing as cosine of 4x all cubed. Okay, so like if I were to break this down, and I'm actually going to start on the inside because I find that easier, h of x would equal 4x, g of x would equal cosine of x, and f of x would equal x cubed. Okay. Now, the way that we did chain rule with the M&Ms, I feel could get a little difficult here. I have an easier way to think of it. You can remember it as ETA, exponent, trig, function, and angle, and you're multiplying all three of these. So again, here's an example. We've got sine to the 4th power of 2x squared, which again can be rewritten as this, which if you find that easier, I would do that. Okay, so to find that derivative, we're going to deal with the exponent first. We're going to find the derivative of the exponent only, and that's using power rule. So in that case, we're just going to bring the 4 down in front. Okay, we're going to keep the inside the same and subtract 1 from your exponent. So that's just finding the derivative of the exponent, power rule. That's all that is. Okay, but then times the derivative of the trig function. So derivative of sine is cosine, but keep the angle the same. And then the last thing we'll do is multiply by the derivative of the angle, which is 4x. And then honestly, the only thing we could do to simplify this is multiply the 4x times the 4. And most times we would bring that in front. And you can really see why we call it chain rule in this case, because you like end up with a big chain of factors because you're multiplying all these, okay? All right, and then the last example I want to show you is, we can also bring a product or quotient rule into these problems. So here we have to use product rule. This is f of x, this is g of x. All right, step by step. F of x is x squared. F prime of x, jumping ahead. Okay, g of x would be sine, and I'm going to rewrite this, of 2x all squared. Okay, so to find that derivative, I have to use ETA. So I'll bring the 2 down in front, subtract 1 from the exponent, times the derivative of sine, which is cosine of 2x, times the derivative of 2x, which is 2. And then let's go ahead and simplify this. Okay, then product rule. Okay, so h prime is going to equal x squared times 4 sine of 2x cosine of 2x plus 2x times sine squared of 2x. All right, and then honestly, well, you can definitely multiply the 4 and the x squared and make that 4x squared. Okay, times sine of 2x cosine of 2x plus 2x times sine squared of 2x. There is some factoring we could do here to simplify. So again, this is a term, this is a term. What's common in both terms? Well, if you look at the 4x squared and the 2x, we can factor out 2. We can factor out a 2x, and we can actually factor out a sine of 2x. That's common to both terms. Okay, so in our first term, that would be 2x times cosine of 2x plus, in the second term, because we took out one of these, it'll just leave 1 sine of 2x, or sine of 2x to the first power is what I mean, okay? And then that would be factored form. which in most cases on the AP exam, multiple choice, they'll have the choices factored. All right, you guys, we're going to stop there, and we'll definitely practice this some more in class. Have a good night.